We get started?
Sure.
All right, so this is Dr. Raj Amanabrolo, and he is a researcher at AI2 at the moment, and a leading expert in interactive fiction games and research, both in creating the games and in creating agents that play them. And he's got his Zork 1 swag that he's showing off today.
gotta rep them.
Yeah. All right. So whenever you're ready.
All right. Thanks for the intro, Laura, and for the invite. So I figured today, since it looks like you guys discussed light very recently and went through all the data sets and all of that, I'm going to be talking about light. So specifically, I'm going to talk about interactive situated dialogue, and you guys might have read or at least looked through the original couple of light papers. So I'm going to talk about those, and I'm going to talk about sort of the immediate follow-up, which is cutting edge, I guess, in that it will actually be presented at ACL next month for the first time. So yeah, let's get started. So to sort of set the stage for this as a bit of a higher level motivation, I want you guys to first think about how people talk to each other all the time in the world, right? People affect change using natural language, and a solid chunk of our communication is grounded in real world actions, right? So let's think about using that kind of communication to help train agents that operate on language. And when I say this, let's make it a little bit more concrete, right? Let's first look at the negatives of what current AI can't do. So why is it that, despite sort of all these advances in the last few years, agents that communicate with people and each other they're frankly quite primitive, right? And so this is, I guess, in my head, this is the reason why no one uses Alexa or Cortana or whatever, right? You can't plan with them. They don't learn from feedback. And they don't really say things that make use of quote unquote world knowledge, right? It's really hard for them to, contextualize what they're saying. So that's the sort of main question, and the sort of key motivation behind a lot of this is what exactly is needed to get automated agents to do the things that humans do so easily. So the first, to do that, we actually have to figure out what the current trends are in, sort of the wider AI research, and correct for those. And I'm talking about one trend in particular. So, a picture is worth 1,000 words, and so a meme is worth 10,000 words. So this actually explains my feelings pretty well about what I like to call the law of large text. And you guys have probably played around with, some form of GPT-X in class at this point. And, they're really good at, doing things like coherency, maintaining context over short bits. But again, taken to any sort of longer length, I know you've talked about storytelling and whatnot. They're not really capable of these kinds of things. They're not really capable of, interactively learning from feedback, contextualizing what they're saying, grounding what they're saying in an environment, right? So, maybe GPT-33 will be conscious. It'll have, 50 trillion million parameters, but maybe then we'll have competent AI. And, that's possible, and I won't rule it out, but barring that timeline, we need to make changes in how we're teaching our, models, these kinds of things, towards moving closer to, natural language competency. And so I'm going to try to make the case to you today for two specific components of learning, right? So again, I'm not going to make, too many parallels to humans, so you won't hear me say things like, we're teaching agents as a human baby does or whatever. But that being said, there is decades of work on grounded cognition and developmental psych work on how people learn things. And two of the key parts of learning things is interactivity and grounding within an environment, right? So it's not unreasonable to try and draw some inspiration from this. And also, probably as you've seen by now, most data sets for all these kinds of language models, all these like natural language tasks that we see are static, right? They're kind of just floating in the air. You have a train and a test and a dev sort of split. A person releases the data set once, you get state of the art, you're done, right? There's no interactivity. There's no like this idea, hey, the world is changing. Facts that are changing, from 3 years ago are no longer valid today. Text that you've read or memorized from Reddit 3 years ago could actually potentially be completely wrong today, right? So, like a factual question like who won the last World Cup, that basically, depends on what the last World Cup was, right? So what I'm trying to get at is,
Right. I actually, sorry to derail this, but I just, that reminded me of some point that I heard last night of how the internet is becoming like so filled with automatically generated text that soon we're going to be training on that as well when we scrape the internet. And so we're just going to have this like weird feedback cycle and none of it will be human generated.
I think that actually happened to Google for their machine translation system. Like it became so popular that when they crawled websites to collect parallel data, at some point they got a regression to previous versions of the system because they were just training on their old data.
Yeah.
That was from a while ago.
Sorry.
Yeah, no, it's a good point. And like, this is the case with images too. I was actually talking to some like vision people, and it turns out that with like, all these like clip and dolly based kinds of things that are spitting out like AI generated art, there's this like really weird feedback loop that happens where, the models might be getting better, but like the data that's going in is terrible. And actually yesterday, Google released their new giant parameter model. It's like what, 540 billion parameters. It's called POM or something. And the sort of main takeaway from that is it's terribly undertrained because like scaling laws wise, you need 15 trillion tokens to train a 500 billion parameter model effectively. And they had two entire orders of magnitude less than that. They only had 70 billion tokens as opposed to 15 trillion. And like the reason for that is because they basically, you could just scrape all the internet, but they had to actually curate like a lot of the data to actually make sure it was high quality enough to really train on. Yeah, that's a good point. Right. So back to what I was talking about. So these sort of two reasons, and let's go a little bit in depth into what I mean by each one of these, right? So like the first common denominator is interactivity, and it's the sort of first term I mentioned earlier. And so it's this idea that we sort of teach and learn interactively, right? It's pretty ingrained, like, like what we were doing right now, Lara and Chris started talking, I'm like responding back to them. So the things that we say or do is refined in a sort of trial and error process, right? With a tight interactive feedback loop. And, it's so like widespread that even within pop culture, one of the ways that we tell that an AI has sort of human level intelligence is how it displays its communication skills, right? Whether it can interact and teach back and forth. And so, that seems to be one key component of language competence. Okay, so there's things happening in chat. What is?
That's just me.
Okay, nice. Yeah. Also, yeah, guys, feel free to like interrupt with questions. And if there's things in chat, Chris, one of like either you or Lara, just like interrupt me.
Yep. Will do.
Yeah. Right. So let's see. Right. So the next bit of this, and what I mean is situated, right? Well, so this is the whole, learning to speak contextually bit, right? And it's this idea that the things that we say or do depend on the current context around us and draw from our shared experiences, right? So this is, I guess, intent grounded in shared thought. And it can be anything from a group of people, role-playing characters in an adventure game, right? Dungeons and Dragons, having a common fantasy world that they all sort of imagine themselves being in, but at the same time, extrapolating real life experiences that they've had, right? Camping in the woods, and taking that into sort of a fantasy setting. Hey, okay, so in the real world, I know that camping in the woods requires like a tent and a whatnot. Okay, so throw back like medieval era Dungeons and Dragons. What are potentially items and things that we require in order to camp in the woods there, right? And it can be less fantastical too, right? It can be something entirely mundane, as all of us having a shared agreement that the only real reason that spoons are useful is because they let us eat ice cream, right? This is really the idea of like common sense.
Wait, what?
It is. This is common sense for me, Chris. That's the only reason spoons are useful. Like,
there is no spoon.
Yeah, I mean, it turns out that like some of the agent examples, they turn out to use spoons as weapons instead of like for eating ice cream, which is, I guess, another way of doing things, right? So what is the so when you say AI techniques and you say interactivity and grounded, what is the first thing that comes to mind? Okay, it's reinforcement learning. And like I'm gonna pretend this was an interactive class. I was in the class with you, and one of you got it right. So I'm gonna show you this diagram that some of you might.
Learning, really.
Some of you may have seen this diagram before in sort of like an undergrad like intro to AI class, but I like this diagram, right? So it sort of makes this point, and it's cute. So this is the sort of standard reinforcement learning setup. In basically what happens is there's an agent that's trying to do things in an environment, which is the world, right? With the intent of achieving a goal. So at every single step, the agent performs an action, and then the action changes the world in some sort of way. And then the world state changes and the agent receives an observation, which is basically the change in world state, and also a reward, which is sort of an indication of how close the agent is towards achieving its goal, right? It's basically the feedback, hey, you're doing something right, you're doing something wrong, that sort of feedback. And so this is basically learning by interacting in a situated fashion with an environment, right? So all of the ingredients are here. And so why have people not put 2 and 2 together and made a lot more language-based RL agents, right? So like, why is this not something everyone is working on? And this is basically why, right? So, welcome to my life. And let's try to take an example of this kind of thing in action, right? So all these, whatever, pick your favorite corporate copyright brands. I know Lara's done like Alexa or something with you guys that are running around. Alexa, Cortana, whatever, it doesn't matter. So all of them operate on language, but in this case, the environment is people, right? People make up a part of the environment. And so these things really would need to heavily interact with humans to learn. And interacting with humans is costly, right? Taking up people's time and money and whatnot. And this actually turns out to be so prohibitively costly that this sort of situated language learning is not something that's been particularly well studied. And so again, now this question shifts to, hey, so does there exist a platform on which we can sort of more easily simulate communication that's grounded in real world actions? Sort of taking a little bit of the sort of cost away. And, this class wouldn't exist and I wouldn't be here if the answer to that was not yes. And so the answer is yes. And this is the sort of a solution that we're going with, right? So this is light. And you guys have sort of all seen this before, maybe not with this particular UI, but I'm gonna sort of like go through the important bits of light. So light is, as you know, this sort of large scale crowdsourced text game. And every single step, you receive a textual description of what the world looks like. So in this case, you being an undead warrior with a particular persona, goals and motivations and so on and so forth. You can sort of type in actions for what you want to do in this world. So, you can go to places and the world changes, right? So, you were in front of a water gate, and now, you go south and you're in front of a main castle doors. And you receive this sort of description of what the world looks like. What are the kinds of things that are there, right? So, there's a castle, there's a hall, there's a stable, blah, blah, blah. There's a serving boy, other characters and whatnot. And you can have this sort of like conversation with other characters. So this is a casual conversation between an undead warrior and a stable serving boy in front of a castle doors, right? So a thing that clearly happens every day. So what does this look like, right? So basically, what do these worlds look like from a higher level they can sort of expand arbitrarily. And this is actually an example taken up from one of the other sort of like follow-up light papers in which we sort of do procedural generation for basically connecting like rooms to rooms within light, right? So you can sort of arbitrarily like expand to having, locations, each of these locations having, different characters and objects and so on and so forth, right? Like limits of your imagination. And actually, this wouldn't be a talk by me if it didn't have like some kind of Zork in this, right? And so we can sort of pump up the difficulty of these kinds of environments arbitrarily. Like they can get very large and complex, right? So something like Zork that's been around since what, like 79 at this point looks like this. This is like a map of Zork. You start in one of those tiny rooms on the sort of east-ish bit of the map, and you got to make your way all the way through this, solving puzzles, defeating monsters, interacting with characters and so on and so forth, right? So this is a lot for, agents to sort of keep track of. And this is like one of the things that Light was inspired by. So one of the other sort of key components of Light is human sort of dialogue interaction, right? And to basically get this, again, we can't like escape the need for data. And it turns out that, the sort of benefit of having games like this is we can throw them on the internet. And so this is actually a sort of a simplified two-player version of Light that we threw on Messenger. Actually, I think it's still up. You can probably still play it. I'll put the link up in chat later. And, you receive a character within this as, like a description. So your character, like in this case, they want to have a fabric, whatever, you get a partner character who can be another model or another human. And, you're sort of like interacting back and forth while receiving descriptions of the world and, descriptions of, what you say and whatnot. And every once in a while in between, you get these sort of like, stars and score based on how well you're acting in character and, how like these goals are being affected, like whether you're actually like achieving your goals or not. And so it turned out this was actually fairly effective. And the first month that we deployed this on Messenger, we had like 25,000 Messenger players, and we didn't advertise it at all. Like we didn't even post about it on Twitter, or it kind of just, I think somebody put it up on some D&D Facebook group, and it just kind of became popular there, and people started playing it. And then I think one of the other things that we noticed that like actually really helped in this crowdsourcing aspect is we added a leaderboard. And actually, like having a leaderboard turns out like significantly increases crowdsourcing data quality, which is like another sort of interesting takeaway from this. It turns out if people are actually like interested in the things that the tasks that you're trying to get them to do, they do them more carefully.
You could give that to Kristen for her thesis. That could have been
it could, yeah. I mean that sounds like there's probably a Kai paper in there somewhere if we look at it closely enough on crowdsourcing. But yeah, so what do we get, right? So what we get is we get sort of these like fairly high quality transcripts of people speaking and acting in character in a goal-driven manner trying to achieve their motivations, right? So at this point, what we have is we've got a bunch of these transcripts, we've got a game, we've got sort of like a game engine, and quests and all of these kinds of things, right? And so there's sort of two key challenges in order to actually getting to use these and making agents that can sort of operate in these kinds of spaces, right? And the first challenge is sort of balancing the sort of combinatorially sized state action spaces. And the combinatorially sized bit just means it's in natural language, right? So if you think about it, like the potential space of things that you can say within a sentence, say your vocabulary is a size of 50,000, right? That's like a normal sized vocabulary for something like BERT or GBT, sort of just a token based vocabulary. And every step, there's 50 possible thousand things that you can select from. And so even just generating a sentence of like, 10 words becomes a search space of 10 to the power 50,000. Like possible things that you can say, right? Of course, again, most of those things are nonsensical, non-grammatical, and whatnot, but sort of just naively looking at the search space, that's the kind of spaces that you're sort of dealing with. And the fact is, like, reinforcement learning algorithms, there really didn't exist anything, I guess, like more than a few years back that were able to handle and balance language generation in these sort of like action spaces of multiple types, right? It's usually very small, tiny spaces, 10 to 100 possible actions at every step, or sort of continuous spaces like with robots, right? I'm going to move my robot rotor, like my arm 30 degrees up and, 1.3 inches forward, like that sort of thing. So that's the sort of first key challenge. And the second key challenge is common sense reasoning, right? And it's sort of how do you get agents to interact intelligently with common objects and characters, but it also, sort of keep in mind what their like current like environment and theme and whatnot is, right? So there's a couple components to this. One is sort of affordance extraction, right? So we as humans, when we're given an object, are able to identify reasonable ways of interacting with an object, right? So, given a mailbox, I know that a reasonable way to interact with a mailbox is to open a mailbox instead of trying to eat it, right? But the question is, how do you give an agent that kind of a prior? And we also have sort of thematic and genre knowledge. So given a character or something in this world, knowing that it's in a fantasy world, and if your character is a peasant, right, peasants don't normally address kings as my dude, unless they have a death wish, right? Like you would speak respectfully based on who the other character is, right? And the way you speak to different characters depends on who you are, who they are, and, relative, very complex sort of social interactions that happen here. So let's recap a little bit here, right? So at this point, we've sort of covered, what are the challenges of actually getting agents to work on these, and what we have at this point, right? So what we have is, we have the light game, which is basically the sort of like factorized POMDP. You don't really need to worry too much about like POMDPs. It's just a Markov decision process. But what you need to really care about is you need to care about the fact that there is sort of an underlying game engine that keeps track of what the world looks like, that takes in as input these sort of like actions and dialogue and whatnot, and changes the world and gives out rewards to agents that operate within this world based on whether they're sort of, achieving their motivations in a persona consistent manner, right? And like we also have a bunch of, sort of expert demonstrations of human players sort of acting and speaking in character using this. And so with all of that, we're sort of finally ready to put things together and make, agents that actually like operate on this world. And this is actually what sort of an architecture for the light agent looks like. And there's sort of a lot to chew through here. I'm going to go through these like sort of step by step from left to right. So the first sort of bit of this is the agent, like I said, is environmentally grounded, right? It receives context at every step from what the world looks like. And so what is actually this context? So this is what the context looks like. The context is basically, a text description of what the world is, right? So in this particular case, you're in a dangerous precipice, whatever. It's, information that you potentially have about other characters. So sometimes you know what the persona of the other characters looks like, sometimes you don't. And you can sort of see, in this case, you have a knight in front of you, and this knight is wearing, his armor, he's got a dragon egg and whatnot. And also the context of what has happened in the world for the last sort of like n turns of like these dialogues, right? So, dialogues that's gone back and forth between, the different characters, changes in world state, and so on and so forth, right? And so all of these like text is sort of crunched down together and passed into an encoder, which, surprise, surprise, is a pre-trained bidirectional transformer, right? So think basically BERT. And I said the magic word, I said pre-trained. And it turns out actually in this case, how we pre-train this is pretty important, right? So, throwing agents into these kinds of worlds and expecting them to just know what to do is actually pretty hard. And so this encoder is pre-trained to have some of this common sense knowledge, common sense adapted to a fantasy environment, right? This is what I like to call fantasy sense, right? And so what this is doing is actually, this is, using an existing common sense graph, right? Something like atomic or concept net or whatever, and rewriting facts so that they basically better fit a fantasy environment, right? So this graph has information on, sort of the wants, the needs, effects, and intents that are caused by actions from that particular character's perspective. Right. So, some of the facts that you see here, right? So, the princess, can, explain a situation, and, one particular thing that a person does to explain a situation is they point a finger, right? Or, the Goblin King has healers that provide care for patients. Or, there's undead warriors, there's bandits, there's ambassadors, whatnot, right? So this is basically a lot of things that you can sort of potentially like imagine real world facts, like I was saying earlier, extrapolated to more fantasy kinds of scenarios.
We have a question about the previous slide, or I guess this one is fine. Ishan asked, what's the blue part?
Yes.
For the encoder?
Yes, that's a great question. So the blue part is basically what is actually pre-trained. And the red part, as we're going to sort of see later, is the parts that are sort of like trained during reinforcement learning training. So the blue part is pre-trained using, as an encoder, using atomic and, over like large text and whatnot. And we're going to see a little bit later how we're sort of pre-training all the red bits of this. So like that's the sort of like encoder bit. Is there a follow-up to that?
No, just a thank you.
It's okay, thank you. All right. Right, so like now that you've sort of gone through this this encoder, all your context has sort of been crunched down into one neat little vector. Another sort of like important little thing, as I was saying earlier, is balancing between when you act and when you speak, right? There's sort of two distinct kinds of like action spaces in here. And so in order to solve this problem, there's something which I call a switch, right? And you can sort of think of this as a meta RL policy that decides when a character is going to act, right? When they're directly going to affect a change, like pick up my little Zork swag mug, or say something. And this sort of meta RL policy is imitation learned based on how often humans act versus speak using these like transcripts, right? So we basically, look at these transcripts of humans acting in character with the exact same context, and we're sort of trying to mimic, like, how well, how often humans acted or speak based on this. And so once, the sort of switch is made, the kind of decision on when an agent sort of acts versus when it speaks, it passes it on to one of these sort of two policy networks. And so these policy networks are separate, basically like transformer-based like networks that are sort of trained during reinforcement learning training. And they're sort of trained to output either an action or a state or an utterance given the current state, right? And so an example of an action that one of these like policy networks can sort of output is take the sword from the table, right? So the sort of like very direct interact with the world kinds of things. Or it can do dialogue things, right? It can say something like, hey, give me that sword. And it's one of these two things that it sort of like, balances between. And there's also sort of a third component for all of these actors. There's also a critic. And you can sort of at high level think of the critic as basically an estimate of how good a particular state is with respect to being able to achieve a long-term reward, right? So if my goal is to get a sword, basically states that are sort of like close to being able to get a sword will have higher value than sort of states that are further away from being able to achieve your goals or whatnot. So at this point, we've sort of covered basically the entire RL agent, right? So it takes in this particular input context, it decides if it's going to act or speak, and it like outputs an action or an utterance. And so what happens after the RL agent has talked? And so this is the sort of feedback part of this, right? So when you as an agent speak or act or do something, the world changes. So the environment changes. And this is done in sort of two parts, right? So the first bit of this is, all the other characters within the world also act or speak, right? And you'll see later. So during training, it's like these other characters are actually also other AIs, right? They're other RL agents or imitation learning based agents. And during test time, they're humans. And the environment as a whole sort of changes. So the world state changes based on the things that you do. If you've moved items from one part of an environment to another part of an environment, if you've said something, if two characters like fought each other, if you've killed a monster, all these kinds of things. The environment processes sort of like all of these. And the first bit of this is, there's sort of the world game engine is basically what's checking for this. And it's sort of checking to see if you've achieved your goals through goal state completion, right? And so an example for this is, say, you're a knight and your sort of like goal is, you're a knight, you're on a noble quest to go kill a dragon, right? And this game environment is basically just checking to see, hey, at sort of every step, is the dragon dead? If the dragon's dead, your motivations have been achieved, and then it gives you back a reward saying, oh, good, you did great, you killed a dragon, right? So that's it sort of for like the actiony bits, but there's sort of a secondary bit, which is the speech rewards, right? And this is actually one of the most interesting aspects of having sort of like multi-user dungeon kinds of things where you have different characters interacting with each other. And so when you talk, there's a couple of things that happen, right? So this utterance that you say goes to a DM, right? It's a dungeon master. And the DM basically first rates how natural or contextually relevant your sort of character is speaking in. And it basically gives it back a reward that says, oh, okay, you're giving, you're speaking in character, right? So this is like what I was saying earlier, right? Like a peasant doesn't usually, say things like, they don't address royalty as my dude. And that's sort of the acting in character part of this. And like for our purposes, like basically this DM is again just a transformer that's trained to sort of like re-rank the kinds of like dialogue utterances and output a score on how in character it thinks a particular like character is speaking in. And it gives it back a sort of like a dialogue like reward, right? And that's not the only thing, right? So there's also sort of speech goals that are indirectly linked to the goal state, in that you can say something to convince partners or other people in the world to achieve your goals for you, right? So again, the sort of like knight example, right? So if you're a knight, your goal is to kill a dragon. You can either, try to pull it off yourself, or if it turns out, this dragon is big and scary and you need more help, you can try and convince other people in the world to also do this for you, right? So it's like, you can try to, convince people to get help, convince other knights to get help, maybe drum up support from a local village, this sort of thing, right? And this is basically the sort of like rich interpersonal character interactions that can result from having, goal-directed dialogue in this case. So again, the blue bit here was the sort of like pre-trained bit, as I was saying earlier, and all of the red bits are trained using reinforcement learning with the rewards that I just talked about. And for the purposes of this, I'm actually mostly going to skip through the actual like math and the details of how I do this. And it turns out there's actually a lot that you have to do to actually adapt the RL algorithms that I did in a prior work and like regularizing advantage actor critic, which is a popular policy gradient method. But if you really want to know details about this, email me after and I'll sit down and I'll chat with you about details for this. For now, just know that, basically like the agent is able to produce sort of like contextually relevant actions and dialogue that's conditioned on the sort of input context, and that is trying to maximize the sort of like expected rewards of, achieving the goals through the game engine and also speaking in character. So before I go any further, like let's actually take a look at transcripts of this during sort of like test time in action, right? So this is basically the agent thrown into a scenario as a character that it's never seen before. And this is an example of what I like to call a self-completion, while the agent sort of achieves its own like motivations and tasks, right? So in this case, the agent is a mermaid hunter, and it's talking to a fish seller. And they're sort of in this like fishy like fish store setup, and the motivation for the agent is it's got to hit the fish seller and remind it who's boss, right? And it's this, so you sort of see the conversation happening back and forth, with the right side, the blue bits being the RL agent and the left side actually being like a human that's interacting on Messenger with this. Right. And so, the conversation sort of goes back and forth, and, the human is trying to convince the agent to, just, take the fish, the human probably, the fish as a fish seller has the motivation that they want to sell the fish. And the agent eventually, just gets like irritated with this, and, achieves its goal of doing things itself, right? It hits the fish seller. And then sort of the flip side of that, of a partner-based completion, right? And so, like I was saying earlier, agents can basically achieve goals themselves within this world, or they can convince other people to achieve goals for them, right? And this is an example of a transcript where an agent's doing that, right? So, in this case, the agent is, the king's trusted advisor. And the partner is, a powerful but like aged wizard. They're chilling in the throne room, and you as the agent, as the king's trusted advisor, need to bring the king's pet back to him, right? And so, this conversation, sort of goes back and forth. There's a little bit of like chit chat about, like courtly intrigue, of things that's happening, and eventually you as the agent figure out the sort of like right sequence of dialogues and actions that's needed, that you need to say in order to convince your partner that, hey, oh, I really need to retrieve the king's pet. And, in this case, your partner just achieves their goal for you. They just find the pet and give it to you. And in this particular case, the king's pet turns out to be a pet lion. Yeah, go figure, right? So what does this actually look like, right? So, let's sort of talk numbers, and this is the sort of real test of this, right? And the real test is doing sort of zero-shot evaluations on held out, human like quests and demos for never before seen things, right? And what this really means is we're basically dropping agents into situations and quests and worlds that it's never seen before during training time. And we're seeing how well it operates in these kinds of things across a bunch of different kinds of like pre-training and reinforcement learning, imitation learning methods. And that was a lot of numbers, but there's actually only 3 numbers that I want you guys to care about. And that's the sort of 3 numbers that you see on the sort of screen here. So on the left here, you see basically the agent trained with reinforcement learning, sort of interactively the way I told you before. And on the right here is the sort of current, standard for a lot of like dialogue research and a lot of like basically, big language model kinds of training where the agent learns to speak simply by just reading transcripts of people speaking, right? So in the RL world, this is just called imitation learning, but in the NLP world, this is basically just the same as GPT learning to predict the next word, given like a bunch of previous words, and like just feeding in transcripts, the way we do in large form, right? So we see that if done correctly, interactive learning is twice as good, right? So in over 30% of the cases, the agent is able to, act and speak in character while like achieving their goals when you use reinforcement learning, as opposed to like less than 15% when, they're using sort of like behavior cloning. And, these numbers might seem low, but like as a sanity check, the human performance, which is sort of the sort of upper bound threshold for this on Messenger, when we throw humans into like random worlds and stuff, is about 60%, right? So, the agent in here, at least within the bounds of these kinds of worlds, is in some ways it's half as good as what a human can do, right? So, there's a lot of space for sort of like improvement in this. And it turns out that like, not only is zero-shot performance better, but these kinds of agents are also sort of like much more sample efficient. So this is sort of like reward curves in training as a function of how many interactions it's had with an environment. And not only that is like the sort of like better pre-trained RL agents more sample efficient, so they can learn from like less samples than an imitation learning based agent, but they also get better sort of pre-training like performance, right? And so these are the sort of 2 main takeaways that I want you guys to take from the sort of like first bit of this talk. And it's the, balancing between actions and dialogue is hard, but it's possible. And the way to do that is basically have sort of like an imitation learning policy that flips back and forth between dialogue and, have interactive feedback that tells you when you're saying or doing things correctly, right? And the second bit is, if done correctly, is sort of interactivity in training these kinds of like language models and language agents is much, much more effective than static learning. In that, you're basically letting the agent learn the effects of its action on a world through exploration, right? And so I like to really think of this as an agent being able to build out a data set through interaction with the world that is specifically tailored for itself, right? And it's sort of tailored in the sense that, the agent tries to explore parts of the world that it has not seen before, or on parts of tasks that it's sort of struggling with. Right? And it's sort of in stark contrast to a lot of supervised training where every single input sample is treated as equal. And you're sort of just like all feeding it through the grinder and just trying to like maximize and like some kind of like maximum likelihood loss, right? In this case, each sample is treated differently, right? So it's treated based on how much learning potential can you learn from that particular sample. And I think that's the sort of like key thing that this interactivity gets you, that a lot of the sort of static learning that's basically the current like de facto go-to in a lot of NLP research doesn't get you.
That's
right?
really cool. I never thought of it like that.
Yeah, it's how I try to think of like basically, if you think about it, like the agent is just sort of building out its experiences, right? And the experiences that it builds out is basically its data set because it's learning from those experiences. Yeah. Okay, so first part of the talk done. Is this it, right? So have I solved NLP? Is this all that's done? Yeah. Okay. So that should answer it. And so like moving on to, I guess, the sort of like next problem in this is, like I told you guys earlier, that Light was a crowdsourced data set, right? Which means that a lot of the initial quests and things that we had in Light come from crowd workers. And what happens when things come from crowd workers? You get very, very heavily imbalanced data sets. And actually, so this is an example of, I guess, a distribution of quests within Light, as a function of the action verbs within their motivation, right? And you can sort of see that it is super skewed, right? So the majority of quests are like, sort of from left to right. The majority of the quests that, humans have decided to crowdsource for agents are, just fetch quests, right? Get, or, give people things, hit things, fetch and kill quests. And if any of you guys have played MMOs, you know that is basically most of questing, even for real game developers. When they don't know what to do, they will just give you fetch and kill quests. Right?
Although probably Hug is not in the top 3 for MMO questions.
Hug is probably not in the top 3 for MMOs. Yes, that's fair. Right. And so, like, if you think about it, so what's really happening here is we get agents that sort of like learn from the head of this distribution, right? So the bulk of their learning is coming from these kinds of like, get, give, hug, hit quests. And a lot of the rarer sort of quests that you sort of like go towards the end, make a particular thing or steal something, or, show something, drop something, like these kinds of like quests are much less seen, right? Sort of during training time. And so like I had this hypothesis that, agents are learning from the head and they're memorizing the tail. And so when they don't see too many samples of a particular kinds of quest, they just sort of memorize exactly how to do it within the context that they've seen it before, right? And what that does is that sort of adversely affects their ability to adapt to new situations, right? If you just simply memorize a particular scenario, like directly how you're going to do things, you haven't really learned how to do it, right? So what you're trying to do is you're trying to learn how to like apply a particular, concept, like, getting a quest, or like getting a particular item or whatever. Right. And that's the sort of like idea here. And it turns out like this is the case with not just the kinds of, quests that you have, but also on the nouns, right? Basically the characters and the objects on all the entities that you see within the world, right? This world has like a very, very sort of like disproportionate amount of kings, right? Like there's usually not more kings than like peasants. At least, like sanity check, but when you give game developer, you give crowdsource people these kinds of things, they like to make it interesting. And so, how do you get things to be interesting? You put a lot of kings and weapons and whatnot within them. which like is great, but like again, this sort of like, if most of your interactions during training are spent interacting with kings, like if during sort of like test time at 0 shot, like if you see a new character, right, that's not a king, you're kind of lost on like how to interact with new characters in sort of like new sorts of scenarios and settings and whatnot, right? Right. And so this is kind of a problem that like it's not unique to this sort of setting, right? This is actually a thing that I think is happening in a lot of like language-based environments, like having this sort of like Zipfian power law distribution of things where it's super skewed, where like a few kinds of like few tokens are found very frequently, and there's like a bunch of other tokens that are very, very rarely found, right? So this like, agent is learning from the head and, memorizing the tail, right? So how do we solve this, right? So I thought very long and very hard about this. And this is basically like real-time sample, like, image of me when I figured out like what I think would be a potential solution to this, right? So what if you just prevent the agent from memorizing the sort of tail of a distribution by getting rid of the tail, right? And that sounds really good in theory, but how does that look like in practice, right? So is the obvious like immediate solution to getting rid of the tail of a distribution just means collect more data, right? Throw more money at the crowdsourcers and force them to basically give you quests that are not fetch or kill quests, pay them more money. That would probably work actually, like if money grew on trees. So for some reference, the original budget for light and light quests was upward of $250,000 for Turk alone. And it took us nearly 2-something years to iron out the process. Like starting with like Jack and like Jason Weston over at Fair, and if like later on when I sort of like came in, basically because of the insane complexity of this kind of like crowdsourcing task at hand, right? Like what we're doing is we're basically asking people to become game developers and testers effectively, right? Like help us make these semantically rich interactive worlds that are sort of, consistent, quests can be completed, right? Like, Chris will tell you that, that $250K for Turk it's basically an NSF career grant. And even with like getting money from Fair and like Meta and Zuckerberg and whatnot, it's not really viable to sort of keep arbitrarily like increasing this data collection budget. And so we need a smarter idea on how to correct for these sort of like distributional imbalances within crowdsourced data. Here's the solution, right? Procedural content generation, right? So in reality, how this translates to what we want to do is it turns out that we can actually use the original data that we have to augment the initial crowdsourced data by training a procedural content generator that can sort of selectively, give us quests and worlds that have characters and objects and motivations of types that are seen very rarely within the initial distribution, right? And so it's this idea that, if we can get one of these procedural content generators to sort of, like work half decently, you have a lot more fine-grained control over what an agent sees during training, right? So you can basically prevent an agent from seeing this sort of like very skewed distribution of quests. And so the first bit of this is this sort of like, joint, world and quest generation. And, there's like a few bits to this that you see on the screen here, right? So sort of starting at the top left of this, like you're selecting like an initial character from your big pool of like characters that you see, you can sort of skew this on an as needed basis towards, more rarely seen characters. So, you have your sort of initial character, which is a dragon. And, based on that, where is a dragon most likely to live in, right? So you start your initial world building based on, generating the sort of location. And so, we think a great place for a dragon to live is a dangerous precipice, that overlooks a little valley and whatnot. And given these sort of initial character and I guess the location and whatnot, we're able to then generate a motivation and a goal for the agent. Basically, think like GPT based. So, given these two things as context, just straight up just generate motivations and goals for the agent. Of course, you can sort of control, lexically, what this generation looks like so that it gives you, motivations and content that you haven't seen, too many times before, right? And so at this point, you have a sort of a seed character that has a motivation. You have one initial location within a world. And then you're sort of basically using that and building out the rest of the world around it, right? So the first sort of key bit to this is, given this sort of motivation, we need to make sure that the agent is in a world where it can actually achieve its motivation, right? So say, you've generated this goal or motivation that your dragon egg was stolen by a knight and you need to punish the knight, right? So, okay, so if your motivation is you need to recover your sort of dragon egg and you need to punish the knight, well, that means this world, somewhere in it, has to have a knight, and this knight has to have a golden dragon egg, right? And that's basically how this sort of iterative world building process happens. So given the sort of seed location, you're sort of retrieving, other sort of neighboring locations that you think could potentially be next to a precipice, like a forest or a castle or whatnot. The characters that are there, and the objects that need to be within each one of these locations, but sort of focusing specifically on making all of these worlds and whatnot consistent, in the sense that your motivation needs to be achievable within this particular world, and also they need to follow common sense rules, right? You can't just place locations and whatnot and characters in places arbitrarily, right? Kitchens are normally not found in swamps, right? This is not Shrek, right? So a knight needing to slay a dragon needs to have a dragon within the world, and vice versa, right? A dragon that needs to recover an egg from a knight needs to have a knight in this world. And this is sort of the key ideas behind this sort of procedural content generator that can sort of sequentially, iteratively make these worlds and quests for these agents. Okay, so given this sort of content generator, it turns out we can actually finally correct for the sort of distributional imbalance that I was talking about earlier by generating sort of curriculums, right? So think of I guess the sort of closest example is, human curriculums as they advance through, grade school and go up, right? Basically, you start with something easier and you steadily go on to something harder, right? So in this case, the curriculum for the agent starts at something easier. So on the far left, you see the sort of quest distribution for the initial crowdsourced data, right? And, this is actually pretty easy for the agent because 90-something% of these quests are just fetch and kill quests. And the agent can sort of very easily learn how to do them. And the rest of them are sort of just memorized. And sort of going left to right, each one of these quest pools has steadily increasing difficulty. And in our case, the sort of steadily increasing difficulty is based on, how many quests do you have within your current quest pool, and how rare are they from your sort of original quest pool, right? And so you can sort of see in practice what that means is you're sort of flattening this distribution from being sort of like a power curve kinds of like exponential distribution into something that looks a lot more like a normal like distribution, where the distribution of quests across each of these kinds of like types is a lot more even. And what the agent does is the agent sort of like trains steadily across each one of these. And it turns out that like we actually don't even need to explicitly correct for entities as part of the sort of procedural like generation. Is all we need to do sort of, going back to this procedural generation, is the only bit of this that we really need to control for is when we're generating motivations and goals. We just need to control to basically make sure that we're generating quest types with the correct verb more from sort of the less seen quests. And because everything else in the system after that is conditioned on that, it automatically corrects for the distributional imbalance within the nouns. So the top bit is the verbs, the distribution of the verbs in the quest pool, and the sort of blue bit is the distribution of the nouns. And so we haven't really even corrected explicitly for distribution of nouns, but by correcting for verbs, because everything is sort of conditioned on that, it sort of like automatically starts flattening the noun and entity distribution within this, right? And so, we're sort of back to where we started, right? And we're using the same sort of like evaluation metrics that we've sort of seen before on a couple of the different kinds of like encoders. So basically, just training all of this from scratch, or like pre-training, like I talked about before. And there's like a couple of baselines, right? So there's the sort of like naive baseline of having a sampled curriculum, right? This is like a very popular idea in the sort of like RL world that's being used. And the idea is like, when the agent is trying to like do quests, you basically just force it to do more quests from the initial quest pool of types that it hasn't seen before, right? So like if a particular quest type is sort of like less seen, and the agent is doing less well on it, you're sort of just forcing it to do those a lot more, as opposed to the generated curriculum, which gives you a little bit more sort of like diversity within the kinds of like worlds and quests that you see. And so these are actually the numbers that I want you guys to really look at. So like basically the biggest takeaway here is that it turns out that like all curriculums help regardless of pre-training, right? So whether your agent is pre-trained or not, or whatever, it doesn't matter. Having any sort of like curriculum that sort of like steadily corrects for the sort of like crowdsourced data imbalance helps. But in this case, like what really like helps is the extra diversity from the generated curriculums, right? And you can sort of think of this as in like, if you're having sort of sampled curriculums where you're forcing an agent to do a quest that it's seen a lot before, just doing the same quest, like repeat it over and over and over again. Like what's really happening is it's unclear how much the agent is actually learning from it versus just memorizing it, like how to do that particular quest, right? Whereas if you sort of generate an environment, like if you diversify the kinds of like worlds that the agent is in, right? So the sort of like domain randomization, it learns a little bit more generally on how to apply a particular concept, right? Like a steal, like the concept of steal, and in different kinds of scenarios, interacting with different kinds of characters, and so on, right? And so that little number, that 0.506 number, it actually ends up being the sort of like current state of the art on this. And if you remember, like from the first part of the talk, like when we didn't have curriculums, agents were getting about 30% performance in achieving, goals and whatnot when thrown into new scenarios with humans. And we've bumped that up from 30% to about 50%. So like quite a significant gain. And it's about 2/3 of the way now to achieving sort of like closer to human level performance, which is something around 60-something%. Right? And so there's just like this idea of having procedural content generators that sort of bootstrap from a initial like small tiny set of crowdsourced data to then sort of like distributionally correct for imbalances that would otherwise be very hard to correct for with humans, and sort of giving an like having a lot more control over what an agent sees. I think is the sort of like key idea for how we need to train agents in this world, right? So key takeaway. Okay, yeah, actually, first main takeaway is this actually really works for me. I don't know, like my PhD advisor like this as well. When I was doing meetings with him, I would basically I would show him like a meme to start off the meeting, and then that meme would be like our motivating meme for like writing the paper. And I basically showed you the motivating memes that led to both of these papers at this point. And it turns out it actually helps me write. Okay, actually though, like the actual takeaways of like what I want you guys to sort of like remember from the sort of second half of this talk is that we can correct for these sort of like distributional imbalances within large crowdsourced data sets. Getting crowdsourced data is expensive, it's hard. Curating Turkers is messy, right? Like, and the more complex your task is, like the richer information you want from crowd workers, the harder it's going to be for you, right? And one of the things to help with that is obviously turn it into a game, leaderboard it, whatnot, and force basically people who are sort of already interested in that task to like do the task, as opposed to general crowd workers who are like, I guess, more optimizing for like times, money given per time spent kind of thing. And two, like even then, crowd workers are, they're biased, they're, they've got like imbalances in what they say. There's actually another really cool like paper on light, which was written by some of my colleagues over at FAIR, like Emily Dinnan. And that paper is called like, Queens are powerful too, right? So if you look at the sort of distribution of this back, like all the way here, like the most seen character in this world is kings. And like queen is all the way in the middle somewhere. So like there's less than half as many queens as there are like kings. And so you get like a lot of things like gender bias and whatnot that's also done in this. And actually, like even before we used any of these data sets, we actually had to like spend a lot of time like debiasing like data sets in order to sort of get rid of some of these kinds of like like inherent gender biases and all these sort of some other like harmful biases that you see within the data. And I'm saying that like one potential way of sort of correcting for like a number of distribution like imbalances and biases is to train content, like secondary sort of content generators that bootstrap off of your initial data, and that you can sort of then just like force into generating exactly what you want them to generate, right? And again, the sort of like final bit is, we've basically are doing zero-shot performance, right? In the sense that like the agent is just dropped into a new world. It's given like no reward feedback or whatever. There's like no updates to its sort of like neural network or policy being made as it's dropped into a new world. It's sort of just directly like, interacting in new situations with humans or other agents. And, basically the performance that we've shown, it's telling you that, we are able to make agents that are somewhat consistent, right, with their motivations in terms of the actions that they do, and natural, right, in terms of the things that they say, right? So they like are, speaking within character, but also speaking and acting within character in a way that gets them closer towards moving to their goals, right? And so, is this it? Are we done now? We're done with this talk, but if this problem was actually solved, I would be out of a job. And so like there's obviously this problem is clearly not solved. We're still only about 50% performance, as you've seen earlier. So there's a lot of space for improvement. You know, I'm working on these kinds of things. You know, Chris and Lara are working on their own versions of these kinds of things. And you know, there's plenty of people. And you know, you can find a bunch of other people working on these kinds of things at that link. That's basically the sort of like rest of the light papers. And I should also pitch that we're doing a workshop at NACL in Seattle later this year that will be both virtual, so we're going to stream it, and like in person. It's called the Wordplay Workshop. I'll put up the link in chat in a little bit, where we're trying to bring together basically this community of interactive fiction people, reinforcement learning types, natural language types, you know, story narrative types, sort of all in this one place to like explore this idea of interactive and grounded language learning. So I figured this might be potentially an audience that would be interested in that. So
Yeah,
yes, that's basically it.
Awesome.
Thank you
Thank
so
you,
much.
Raj.
Does anybody have any questions for Raj?
Okay, so I'm also very interested in your idea about the curriculum, but I'm not pretty sure how you train a curriculum model. Does it mean that you train step by step with more balanced data? And the balanced data is more, it's much more smaller than the previous one, because I saw there is a like n equals to 64 to n equals to 2. What's the difference here?
Yeah, that's a great question. And so basically, like what we're doing here is the generated data is not actually smaller. The generated data, like, so if you look at the scales on this really closely, so on the left here, the scale goes where the king, where the sort of like most given quest, which is like the leftmost is 50% of the data. And on the rightmost curriculum, that 50% of the data is now like sort of shifted, and every single thing is only 5% of the data. So the overall number of quests is the same. It's just that like we've sort of replaced a lot of the quote unquote like unnecessary like additional like you know, hit and whatever like fetch and kill quests into, and like, you know, push those into, you know, some of the other types. And as far as like how each of these things are trained, like I skipped like over the details of most of this, and you can definitely read the paper and chat with me. But like some of the details of this is we're basically just we're training effectively like GBT, like BART style, like sequence to sequence models that, you know, given like initial characters and locations, and we're training them to generate you know, the motivation and the goal. And the thing about having a model that can generate it is there's a bunch of like techniques and sort of like constrained generation where you can force a model to generate a quest of a particular type. And you can basically force it to just have a particular output verb within the sentence that it generates. And that's kind of how this sort of like distribution of curriculums is done. So sort of going left to right, you know, you're just forcing the generator to generate curriculum of a particular quest type. So the overall number of quests that the agent trains on sort of stays the same, except, you know, you're getting rid of like a bunch of the excess. You don't need 50 million like kill quests to learn how to do a kill quest. And you're shifting that into something that's sort of like more rarely seen. I hope that answers your question.
Yeah, so you train 4 models on this 4 graph that more balanced, with more balanced generator output, right? Generated data.
Yeah, basically. And so the really good thing is, like, you know, you basically, you just have a global view of your entire quest pool at any step, right? So you're generating all the data. And so you know at any given point, like how many types there are of each kind of quest within your data, and you can calculate the distribution at any given point. And so if you can calculate the distribution, you can basically look at things like skew and whatnot, and you can look at like what are the more rarely seen quests, and you can force your generator to generate from the things that are more rarely seen, right? And you know, sort of from like statistically speaking, like this is basically, it's called fattening the tail of the distribution, because you can calculate what the tail is and which verbs belong to your tail. You can basically force more of those kinds of quests into your curriculum.
Yeah, I just want to follow up one question. So how do you force the generator to generate the